Ladies and gentlemen, we have reached the last session for today on the topic DDGS Decanters, Protein and Corn Oil Recovery. I would like to introduce our speaker for this session. Mr. Martin Neugebauer is a process engineer with more than 18 years in the separation business. Can we please have a huge round of applause for him and welcome him on stage? With more than 18 years in the separation business, with a strong focus on starch, protein, and bioethanol applications. Being responsible for the complete renewable resources business line and specialization of the corn oil recovery process with 3-phase separators. He is heading the business line of renewable resources at GEA Westfalia Separator GmbH, Germany. Let's please welcome him on the dais. And along with that, I would also like to extend our welcome to Mr. Rajesh Chabra along with Mr. Sunny Tokus. A very, very warm welcome to you. I request you to join us on stage. Can we please give them a hand? This is our last session for the day. We have a timer for you for 35 minutes and we will have a quick question answer round after this. Thank you and over to the panel.
Yeah, hello everybody. Good afternoon and thank you very much for the invitation. It's a pleasure to me to be part of this event. Thank you very much again. And I'm happy to speak here about the oil recovery. And thank you also to Mr. Adapa. He mentioned already the golden solids. I would like to speak about the golden oil. Yeah, just to inform you where we are in the complete group of GEA. Westfalia Separator is the main part of the division SFT. It's called Separation and Flow Technologies and creates even the business unit separation. Our core products are the decanters and separators, and we are doing also business application-wise. So we are very proud about our history. We have celebrated last year 130 years of our company, and we are doing business in a lot of applications. The business line renewables, maybe some words to that, is busy only in several parts of renewable materials. Whether they comes from plant-based or whether they comes also from animals. At the end, our end products are even proteins, starch, but also biofuels like biodiesel and also bioethanol. And I would like to sketch a bit the idea about the ethanol production and what is going on in this area. What is the classical process? I would like to discuss with you the standards that are in Europe and also in US, and will give you some examples how it works, how we can generate the corn oil out of the synstillage or even the syrup after the evaporation. And the main topic is there is some added value in the corn, not only the DDGS and not only the ethanol. You can get out the DDGS and including the fibers, including the proteins, including the oil, what is coming from the germs, and not only the ethanol, what comes from or which comes from the starch. So, and everybody of you knows this standard process where the stillage dewatering is the crucial process step in the stillage treatment itself. And you see here also the evaporation step after the stillage separation, where we can create the DDGS, and the ethanol is produced by the starch during the complete process. So if you have a look to the setup of this special crucial step, then we speak about a synstillage as an outcome, as a discharge of the decanter, and a wet distiller's grain as the second one. This is normally mixed up with the syrup out of the evaporation step, and then feed to the drying system. That must be not a ring dryer like you see here. That can be also other kind of dryer. It's just an example. It's just a picture. But the DDGS includes also the proteins and also the oil. And therefore, we have a look onto that one, what we can do to get it out. In the US, any years ago, they start also with some safety issues. Some of their dryer burned down because of the high content of oil in the DDGS. That was also one reason why the colleagues over there asked for a solution to get out the oil. Just to inform you a little bit about what happens in a decanter. Decanter consists of a drive system on the left-hand side. You see here we have a rotating bowl, and in the bowl there's also rotating a screw, which is conveying out the solids which are settled on the inner bowl surface. You have on the left-hand side even the solid outlet of the wet cake, on the right-hand side the liquid outlet of the thin stillage. The main job of a decanter, of a stillage decanter, is to dewater the stillage as much as possible. So then you can save on the drying system a lot of money, a lot of energy. So each and every percentage what you can dewater mechanical wise, you save money on the dryer side. Just have a look onto the characteristics of the feed input to a stillage decanter. You see on the left-hand side a spin tube where you can see a certain amount of coarse particles on the bottom and fine particles above these coarse particles. And what I would like to say, or what is the main message here on that slide, you see on the right-hand side the spin tube of the thin stillage outlet of the decanter. And you see also the fine particles over there on the bottom. That means fine particles are not catched by a decanter. Fine particles will partly remain in the thin stillage. And at the end, you have to proceed it via your evaporator. You have to proceed it also furthermore in the process. There is a huge range. Don't thinking about the nomenclature, don't thinking about the names of the decanters. What is important, there is a huge range available from 400 millimeter diameter up to 800 millimeter diameter, so that you can proceed on the stillage up to 90 cubics per hour of stillage. And I think you know that the wet cake is around 30 up to 35% dry substance. Now I would like to tell you something about the alternatives. Up to now, we have a process set up where we don't recover any oil. Oil is proceeded via the dryer, and it's still in the DDGS. So what we can do, we can, of course, with a solution to recover the oil, making the complete process a bit more flexible. So from the economical point of view and also from the adjustment of the DDGS. Some farmers would like to have the DDGS with a higher oil content. Some farmers would like to have a lower oil content. It depends on the final usage of the DDGS. And from that point of view, if you can separate the different byproducts, you are more flexible in proceeding your plant. I mentioned here also the two-phase separation for mainly other grains. Mr. Adapa told you a lot of rice and rice protein. Maybe that could be an idea. We know that very often from the wheat starch-based bioethanol production in Europe, that they are taking out the proteins for further treatment. They are looking for the proteins to develop the properties of the proteins furthermore. Let me tell you something about the content. The colleagues in the US, they are talking about 1.8 pounds per bushel of corn. That is the content of oil, what the germ is bringing with it. And in the standard recovery, that what we are doing usually in the US and in Europe, we can get out 0.8 up to 1 pound per bushel of corn. And I will show you later on what we are doing in the setup to increase even this yield up to 1.5 pound per bushel. So that is the value finally for you as a bioethanol producer to creating more money, to creating more earnings with a higher yield. We had also some words from Mr. Adapa about the usage of the oil, and the main usage is, of course, biodiesel. But he mentioned also that it's usable for the so-called green diesel. It's also called HVO. You have heard that probably. This is an alternative to the crude oil for the refineries to use also even edible oils or used cooking oils, for example, to produce a standard diesel. Of course, you can burn it down to generate power. And as I said already, some of the farmers dosing it back in that amount what they would like to have on the DDGS. And if you go a step further, of course, with the dedicated refinery, you can also use that kind of oil for ingredients in cosmetics application or even in food. But we have seen that not so often, I have to say. I made a roughly calculation based on a typical plant size in US, which are treating 500,000 tons corn a year. The oil content based on these 1.8 pounds per bushel corn is approximately 60,000 tons of oil. And with the standard procedure, we can earn approximately 7,500 tons a year. And if we switch the setup, if we change the setup a bit, then we can generate also up to 13,000 tons a year. That is a huge amount, and also a lot of money what you can earn at the end to make your production more profitably. What we are doing in the standard process of oil recovery, we are using on the syrup side at the output of the evaporator, we are using a 3-phase disc stack separator. I will explain you later on why we do not use a decanter or a 3-canter. From that point of view, we have here a 3-phase separator installed for many years. As I said, in the US, it starts any years ago. And at the end, we can generate the corn oil, and on the other hand, a de-oiled syrup and also the solid phase, which comes out of the separator by ejections. And with that one, you can, of course, getting added value by the oil, and you have a less fat content in the DDGS. And we spoke already also about the protein content in the DDGS. If you take out something, then by percentage, you increase, of course, the protein content. Due to we keep the proteins into the DDGS. Yeah, and the safety reasons I explained already. You save your dryer system when you not have so much oil in the feed. Let me explain some words to the differences between a 3-phase decanter and a 3-phase separator. The 3-phase separator has a definitely smaller footprint. It's more easier to install. We can handle also up to 40 cubics per hour throughput capacity, and we have definitely a higher clarification area due to we have these amount of discs in such a separator. We can also catch also the smallest droplets of oil. So the efficiency of such a separator with a G-force of just around 8,000 G is definitely higher and better than a decanter can realize that. With approximately 4,000 G has a less clarification area. And if you have a look onto the service side and to the CIP side, then a decanter is not really CIP able. What you can do with a separator by flushing the separator with caustic or with acids, even also just with water. So from that point of view, you have some advantages on the separator side, and in the US and in Europe, we use that system very often. That is a picture to characterize the syrup. And you see, this, after the evaporation, we have a higher concentration on solids, and it's just like I would say like a curd or like a syrup. You see not really defined particles or solids in this spin tube. It's a kind of mesh, but on the top you see approximately 2 up to 5 volume% of free liquid oil. And that is important for us. If we would like to separate it mechanical wise, then we need this free oil. And the high G force allows us to press out the oil and to, let me say, maybe it's not the right word, to destroy the bounds between the solids and the oil, which is existing, and therefore you can use demulsifiers to optimize that point. And on that stage, you have definitely to use demulsifiers to get out the oil, to create the yield what is necessary. I'm missing some. Okay, sorry for that. What we are doing now is we switch the position from the older system, from the syrup to the thin stillage side, where we can generate up to 50% more yield than in the former situation. That is based on experiences. We have 2 plants running, one in Latin America, one in Europe. That's why I name it sometimes new standard. The big advantages are we have to proceed the thin stillage, which has definitely a higher amount, a higher throughput capacity than after the evaporation. We have a smaller amount of free liquid. You see here only 0.3 up to 1% free liquid, free oil, what we can separate. But as I mentioned already, the efficiency of a separator is so high so that we do not need any demulsifiers here in that case. Demulsifiers helps at all, definitely, but you can reduce that to a certain amount so that you save also on that side a lot of money. Additional advantages are definitely you can saving costs also with the deloading on the evaporator side. As I mentioned before, the fine particles will remain in the thin stillage, and we can take it out with the separator here on the thin stillage. And you spoke also a lot of the protein recovery. That is also possible with that separator. In these fine particles, the proteins are included. Not at all, but the main part of the fine particles is based on the protein phase. Some of the customers are using these proteins, as I mentioned before, for separate or typical, or let me say, dedicated developments, but most of the customers are using the proteins on the DDGS. So they bring it back to the wet distiller's grain to dry it and to have the proteins as it is in the distiller's grain. That is the value for the DDGS, finally. To show you what is the impact of using demulsifiers. I said it already that I made a calculation based on a typical plant in the US. They will earn on the ethanol side maybe $120 million a year, $7.5 million oil, and they have to pay for the demulsifiers just around $360,000 for the demulsifiers a year, if they have installed the corn oil separator at the end of the evaporator. If you are using a decanter, then they have to pay a bit more for the demulsifiers. So they have approximately to invest $540,000. These data we have from our customer side, so it's not on our side, but it means in this standard process you can save additional $180,000 during the operation of the plant if you use a separator instead of a decanter. So, and that shows you at the end the efficiency of a decanter is lower than the efficiency of a separator. That is the main message. And if you speak about this new setup, then we are using the separator, the three-phase separator in front of the evaporator on the thin stillage, then we do not need any demulsifiers, or only a less amount. Yeah, when it comes to the separators, what we have to use, then we speak about typical machines with the names of RSE 80 RSE 90, RSE 110, up to 300. And that means at the end we have throughput capacities realized up to 40,000 liters per hour, 40 cubics per hour. And by the way, yes, you have to install on the syn stillage maybe 2 separators instead of 1 after the evaporator. But at the end, it's a calculation on the cost side. You have invest a bit more in the capex, but you earn a lot of money and you save OPEX costs on the demulsifier side, on the efforts to clean up the evaporator, to run the evaporator. And all these things will generate a lot of profit for the producers of ethanol and corn oil. Just to mention it, the separator in front of the evaporation is not only a self-dislodging separator, it's a self-dislodging separator with nozzles included, so that we can handle better these high volume stream. And we have a volume stream which is 4 times higher compared to the syrup. So the concentration factor of the evaporation is just around 4. And we need only the double capacity on the separator side. So the capex will be slightly higher, but we use a slightly different ejection system in this kind of separator. But that means that we need some strainers before. What we can provide is a complete PFD or an PNID, so that everybody knows how you should install such separators in a proper way, that you will get the maximum of corn oil for your production. 9 minutes left. Oh, I'm very fast. Sorry. As you know, some facts I can tell you. That's some typical pictures of the stillage decanter. You see the feed, and you see also the outlet on the solid side with the dry matter substance up to 35%. That is what you know. I would like to show you some data. These data are from 2023. Let's have a look only on the right-hand side. The corn oil prices last year were just around $1.4 per kilogram. And nowadays, I checked this shortly before this meeting. The guys in US will get for the corn oil just around $900 up to $1,000 per ton, so that the prices are also vary over the year and over the years, definitely. And the ethanol price in US is just around 3.1 US dollar per gallon. Means, if I calculate it right, means €1, $1, 0.8 to $1 per liter. You know better than me what about the DDGS prices here in India, and also the ethanol prices. So when it comes to our references, then we have a lot of installations. The main one, of course, in US. They started very early with the corn oil recovery, based on different reasons. At the end, we speak about more than 130 separators we have installed, and alone in US. And also in Europe and Latin America, we have erected such installations already. What we would like to plan for the future is to bring up a webinar so that everybody is available, or it's invited to participate a webinar, what we will provide over the next few months with more information to that setup to the corn oil recovery. You can always have a call to me. You can always have a call to my colleagues. And from that point of view, I have to say thank you very much for listening. And yeah, I saved time for the next coffee break. Thank you very much.
spent you samples in your place 6 months ago. When it didn't come back, you what is the oil content in that and what is the viability there? I'm talking of Indian corn, right? You have the
It works. Yeah, it works. Yeah.
the spin tube. He wanted a spin tube of spin wash and the fixer. Vodka.
Yeah. It's
I sent it.
yeah.
No reply.
No reply. Then we will change that. But you mentioned the right point. The corn composition in India is definitely different to the corn composition in US. And the figures I have shown for the corn, the starch content is definitely different to the starch content here in India. And from that point of view, it's very important for us to have these spin tubes, these spin tests. Due to we always thinking about which volume we need in a decanter or even in a separator. We need the space in this area, and we need to know how much volume take even the coarse particles in, or how much space the coarse particles need in a decanter in a centrifugal field. That is very important. And if we speak about a concentration by weight, that doesn't help us due to the coarse particles have a volume concentration. I say just only figures with 10 volume percent, but they have 30% of weight. And we have also 10 volume percent of these fine fraction. And these fine fraction has only 1 or 2 or 3% of weight. That's why it's very important to have the spin tests in front of let me say, in front of designing the right machine for the setup. That's very important. Sorry for that you didn't get.
I want to know in 1 ton how much percent oil I can get out of this spin tube.
Yeah.
I have sent this photos to him, got this spin tube done in my factory, and sent him the photo, but I didn't get how much oil I can accept out of it.
Then I personally will take it up again, and you will get the information as soon as possible.
I think you have all the photos?
He have shown me shortly before that.
I can send further on. Let's talk business first. Right? How much percent I can get oil per ton corn?
Yeah.
As per the indication what he has given, it is very less, it can't be distracted, I don't know what is happening. When somebody is not talking about for 6 months, what I will understand.
Sorry for that. I have to apologize that. Sorry.
Surely. You should tell me the business-wise, this percentage, I don't know much. I want
normally,
I want 2 equal to 3. Right?
Just we will take care about it, definitely.
Okay. We would like you to work on the Indian corn more, because India is going to be a big market, 200 plants. Now in next 5 years, there are going to be 200 plants on maize. Big market. So you should work on Indian maize instead of only US maize. That is my suggestion, sir.
As far as I know, you have in India more than 150 plants based on corn. And from that perspective, most probably nobody or only a few recover the oil out of the corn. So
nobody is recovering because there is no surety whether tomorrow I will run on rice or I will run on corn. I don't know. Future is maize, no doubt, but today maize is not available. The amount of maize which is required for ethanol industry is not available. And it's going to take 5-7 years minimum. So, but by the time you should have your studies to develop your decanter or tricanter or separators for Indian maize, please.
Yeah.
Because here the oil content is little less in the corn.
Yeah, that we have to check, and then
sure.
It's fine.
Please
and then,
check. Let us know.
Exactly.
Thank you.
So definitely.
Thank you, sir. Do we have any more questions? Anybody from the audience? So may I request you to use the mic, please? It's right over there.
Sir, this separator, what you said, since how long it is working in Europe and this US? The separation of oil. Since how many years?
In US? In US, maybe since 10 years or more.
3 years.
10
years.
10 years.
How is the viability and all? Have you checked? Viability.
Sorry.
Viability of the machine that is running fine. Yeah, these machines are running quite good in US and Europe, and you have also seen the reference list. We have more than almost 130 machines in operation. So this is all full proven process machines.
Payback है या नहीं?
वो अभी आपका ट्यूब से निकाल के बताएंगे. Payback period.
That is why.
It's an interesting question also for us. So I can ask our customers what they have to pay for or what are their costs and what their earnings at the end. And honestly speaking, I don't get the correct answer. So
You need to provide all these things. Then only people will come up.
we will do an assumption.
Thank you.
That's definitely.
All right. Anybody with another question from the audience? This would be the last question for the session.
The question is, if we are running two feedstocks at the same time, if it's maize or let's say in the US you're running barley or wheat, whatever, does it affect the extraction of oil separation ratio if it's mixed with another feedstock?
Yeah, if you mix it up,
Yes.
if you have
If it's not
if you have wheat and corn together in the mill, so no differentiation that you can say you run only corn today and tomorrow wheat. When you mix it up during the day, then you reduce the oil content definitely. So we haven't seen that someone is running that in that strategy. You would like to have the oil as much as you can get in the corn stream to separate it. Otherwise, you have to adjust a bit the system, but the oil content will definitely lower. Maybe there is also an impact from the other grains, but if you run it separately, then you have to stop the separator, you have to pass the separator, then you have the standard process.
Like in India, in the ENA plants, you run maize and then you run rice as well, mixed, correct? So the input into the tricanter will be a mix of, let's say, 50% rice and 50% maize. In that case, will the maize oil or the corn oil be extracted, or will it be absorbed by the rice and it will go ahead and it's not a fruitful exercise?
I try to answer that. See, the amount of oil, as we mentioned moments back, oil content in Indian maize is already observed low compared to the American corn. And if you're further adding rice to it, then the percentage of oil is further going down. This will certainly affect the separation performance, because we have less than we expect at least 1% of oil before we can separate it. So you will end up having less pure oil being separated from the separator can work on that. There is no physical deformation happening here, but the purity of oil will certainly go down. So this can be one effect, but again, this is just an assumption. We have no live experience on such blending.
But then if you were to talk about purity, does the purity affect the end product when we're trying to go and sell the product? When it's going for biodiesel itself, let's say?
Of course.
The main issue for biodiesel is the amount of free fatty acids. So, and that you have to check so I have no experiences, and most probably we have also from other customer side no experiences in blending different grains. That we have, maybe we have to run a trial or something like that to see what happens.
So have your dish stacks or tricanters, have you run them on rice? Because let's say rice also, according to one of the gentlemen who was presenting before you, said rice also has 4% oil. So can that also be extracted through your machines or no?
Rice,
No.
I think there is some
No. In rice you have no free oil. As I mentioned before, we need this spin test, and we have to see even this free oil level. And on rice, you do not see that.
It was about rice protein, as far as I remember.
Yes.
And we do have, that's a separate subject. We do have experience with the rice protein separation, but that is not from a distillery point of view. It's a food plant, and it's a dedicated line for rice protein and starches.
What I mentioned, if we have some bioethanol companies, they are running wheat in Germany, for example, and they are using on the thin stillage two-phase separator to take out even these fine particles which are including or which have the protein phase in it. And they are working on the proteins. And maybe you can do it in a similar way on rice. I'm not really sure about that, but that could be an option.
I apologize for intervening. We need to take a quick tea break. We can continue the conversation along with tea. I'm so sorry for intervening. We'll have to just keep in mind the time allocation. Thank you so much. But I think can we please have a huge round of applause? With this, we conclude our series of very interesting sessions for today. And I think the last session has brought us to some very relevant, some very interesting questions. I'm sure the exploration, the exchange shall continue. Thank you so much to the wonderful speakers on the stage and for the audience for bringing forth their thoughts and their questions for us. Please join us for tea. We will see you back in the hall at 5:45 p.m. sharp for the final segment of our program. Thank you so much, ladies and gentlemen. The panel, can we please have a photograph?